Everyone, welcome back. In this video, we're going to look at an example of a confidence interval for the difference between two means. In this example, we are going to calculate that degrees of freedom together. So let's go ahead and get started. We're asked, do piano lessons improve the spatial temporal reasoning of preschool children? So one population down here, takes piano lessons, and this sample mean is the mean or the average of their, um, you know, spatial temporal reasoning score or something, the standard deviation of their scores, and then the variance of their scores as well. And then in our second population, we have preschool children that do not take piano lessons. And so this is their sample average score, the standard deviation of their scores, and the variance of their scores. So we've got our formula over here for the confidence interval for the difference of these two means. We basically have everything we need, right, except for our t-value. And our t-value is, of course, based on degrees of freedom. All right, so let's start by calculating that. I know it looks a little intimidating. I'm going to start it over here. And so we're pretty much just going to put in exactly what we are asked for. Right, I'm going to try to keep all the notation and everything the same. So our sample variance from sample 1 is 9.33. So note, I'm not squaring this again because s of x1 squared is already the variance, right? So if we're given the variance, we can plug that directly in. Remember, the variance is just our standard deviation, which is s of x1 squared, right? So to get the variance, you just multiply the standard deviation by itself or square it. Which is why you see that squared term there, but I'm not squaring it here. So we divide that by our sample size, first sample size, right? Corresponding sample size. So that is divided by 34. And then we add that to our sample 2 variance, right? Which again, if you don't have the variance, you just multiply the standard deviation by itself to get, divide that by sample size 2, which is 44. So these things are inside a parentheses, right? So we're going to add them up together first. We'll have to, do this division to get a decimal number, do this division, and then we'll add up those two decimals. But then we need to square that final number we get on the inside, right? So now we need to take 1 over our sample size minus 1, right? So that's just 33. We need to multiply that by our variance again, the same thing. 9.33 divided by the sample size itself. And we need to square this individual term this time, right? We didn't square this guy by itself up here, but we're squaring him down here. And then so we're going to take that product and we're going to add it to 1 over the second sample size minus 1, so that's 1 over 43. And we need to multiply that by our variance, sample 2 variance over the second sample size, so 5.87 over 44. We need to square this, right? Okay, not too terrible once you plug it all in. So let's take 9.33 and divide it by 34. 9.33 divided by 34 is equal to 0.2744. Okay. You need to add that. Let's plug it in. Add that to 5.87 divided by 44. Let me make sure I did that right. Yep. So now let's do 5.87 divided by 44. And I get 0.133. 334. And now let's just also plug that in. We've calculated this 9.33, right, divided by 34. That's our 0.2744. We still need to square that term, right? That 1 over 43. And to multiply that by 0.1334 squared. Okay. So let's add these things together. Oops. Don't want to forget that squared term. So let's add these things together and then let's square them down here as well. Okay, all in kind of one step. So 0.2744 plus 0.1334. I get 0.4078. And we still have to square this, right? We still have 1 over 33. So if we square 0.2744, just multiply it by itself. I get 0.0753, basically. Okay, and then we have 1 over 43. Now if we take 0.1334, multiply it by itself, I get 0.01779. Okay, so let's square this term up here. If we multiply 0.4078 by 0.4078, I get 0.1663. And now let's multiply 1 over 33 by this 0.0753. So 1 divided by 33 is 0.0303 repeating. So if we multiply that 0.0303 repeating, multiply it by 0.0753, I get a pretty small number, which is 0.002 to 8. So now let's do 1 divided by, okay, so that's this product, right? On the left-hand side of our plus sign. So let's do 1 divided by 43. That gives me 0.02325. So now if I multiply the 0.023, multiply that by oops, 1 divided by 43. If I multiply that by 0.01779, I get 0.0004. Okay. Excuse me. So now let's add those two numbers together. Leave our 0.1663 up top. Add 0.0004 to 0.00228. And I get 0.00269. So now we'll divide the 0.1663 by our 0.00269. And I get 61.82. And so we'll round this up to be 62. We'll use 62 degrees of freedom for this problem. So that was kind of a lot. So we'll pause here, digest this, go back and rewatch the formula if you need to, or the video if you need to. And then in the next video, we'll use our degrees of freedom to actually find the t value that we need. And we'll plug everything in to our formula and find the confidence interval. Okay.